action.
Oh, Bobo.
Oh, Bobo, always bottoning around and eating DC. All right, we're supposed to sketch the graph of x over x squared minus x minus 2. So the first thing I'm going to look at is the powers. I'm going to look at, we have an x and we have an x squared. So I'm immediately going to go, well, it's bigger on bottom. We have x squared on bottom, x to the first on top.
Wait, that's not
Ours
the
is
same
different
one as
than
ours.
yours.
We have 4x over 2x minus 2.
You have what now with the what way?
4x over 2x minus 2.
You did what now with
4x over 2x.
So you have 4x over 2x minus 2?
Correct.
Oh, okay. I guess that'll be easier. This one's more fun. This one has 2 asymptotes. It's pretty cool. So let's change it to what you had and then solve it that way. So we had 4x over 2x minus 2. Well, that changes everything. I was wondering why everyone looks so confused. All right, so we have 4x over 2x. That's what I'm looking for my Bobo Botan. So 4x over 2x, that means we're going to eat DC. We're going to eat DC because the exponents are the same. So we are going to eat DC. We'll mark that. We'll eat DC. Now let's just put that next to the horizontal asymptote. Let's find our horizontal asymptote. Horizontal asymptote. Because they're both the same, we are going to eat DC. And what eat DC says is exponents are the same. Divide your leading coefficients. Our leading coefficients are 4 over 2. That's our division of our coefficients. So we're going to have y equals 4 over 2, which is just 2. Let's find our vertical asymptote. Our vertical asymptote is just where our denominator equals 0, because it can't equal 0, so that's where our vertical asymptote is going to be. So I'm going to set it equal to 0. Equals 0. We'd add 2 to both sides, so we'd have 2x equals 2. Divide by 2, we have x equals 1. I now have a vertical asymptote. I have a horizontal asymptote, and that is the biggest step in graphing these, is graphing your horizontal and your vertical asymptote. So let's go ahead and graph those. Shazam, Shazam. Let's just make some tick marks. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Nailed it. All right, I'm going to say that each of those are 1s. And we're going to say, okay, at y equals 2, we have a horizontal asymptote. So here at 2, we'll have a horizontal asymptote. And we have a vertical asymptote at x equals 1. Well, here you could almost guess. You have a 50-50 shot of getting it right, realistically. Either it's going to be down here and up here, or it's going to be up here and down here. There are rare cases where they're both in the top, both in the bottom, but that's like a 1%. You'll actually, I think you see one on the homework tonight. I think I put a little note by one of them that says this is a special case. So plot extra points. All right, well, rather than just guessing, let's just plug in some points and see what's happening. So I'm going to plug in a point to the left of my vertical asymptote, and I'll do one to the right. I basically want to figure out, is the graph down here, up here, is it down here, or is it up here? So let's go ahead and pick 0. I always pick 0 if it's one of the possibles, because 0 is always easy to plug in. So let's make an x, y kind of action plane. Let's plug in 0. That is basically my left, right? That's left of our vertical asymptote. And when I plug 0 in, we'd have 0 on top, which means it would just be 0, right? I don't even need to plug in the bottom. You can. We have 0 over -2 is still 0. So we're going to get out 0. So let's plot that point 0, 0. Careful, Maya. I don't know where it went. All right. We're good. Everyone can be okay now. All right. Now, I'm pretty sure it's going to be up here. But I'm going to test while I guess at it. Let's actually plug in one of those points. Let's plug in 2. Let's go ahead and plug in 2 to just double check. So if I plug in 2, we'd have 4 times 2, which is 8. Then we'd have 2 times 2, which is 4, minus 2, which is 2. 8 divided by 2 is 4, so 2 would go to 4. Good thing I made this just high enough. So we have a graph that looks something like that. Who is at least close? Are we at least close-ish? At least close. All right. Everyone that wasn't close, do you understand what happened here? What I did? All right, this is a pretty basic one. This is pretty basic. This is about as easy as they come, especially because it's just eating DC. We just have to divide. So make sure if you did not get this, you go back and look at your homework. Go back and look at your homework to make sure you understand how to do this. All right. I'll ask questions on homework after the lesson. I just want to get through it because generally this is the same lesson we had yesterday, just with addition of extra stuff. All right. When we're looking for our horizontal asymptote, so we're using Bobo-Botten, that is for our horizontal asymptote. That's all it takes care of. And you can see Bobo eating his Washington, D.C. there. It's a pretty awesome picture. But let's go through this and do some examples right next to it. So we have our first acronym is Bobo. Bobo is bigger on bottom. And that O isn't really an O, it's a 0. And I always think of Bobo as just being a big dumb guy that just spouts out y equals 0. No matter what numbers you give him, if it's bigger on bottom, Bobo goes y equals 0. No work required. No work required is the only one that you don't have to do any work at all. It's Bobo. Bobo's not very smart. He goes y equals 0. Give him an equation. He goes y equals 0. All right. My example is up here. We have x plus 2 over x squared plus x minus 20. It is bigger on bottom because we look at the biggest exponent. Right. So we have x to the first here and x squared. 2 is bigger than 1, so it is bigger on bottom. It is bigger on bottom. So if I need to find my horizontal asymptote, this falls into Bobo's camp. And Bobo just says y equals 0. No work required. Bigger on bottom is the easiest. Vertical asymptote, I need to figure out where that equals 0. So our vertical asymptote is where our denominator equals 0. So that's x squared plus x minus 20 equals 0. If this isn't factorable, are we done? Do we just on the test write it's not factorable? No, we put in the quadratic formula or we put it where we complete the square. We are never done with quadratic. However, this one is factorable because we can have x plus 5, x minus 4 equals 0. Would I get full points if I say my answer is negative 5, 4? Is that an appropriate way to answer this question? People say no. Can you tell me how to get the full points for it? Yeah. Yep. I need to say x equals. This is one of the cases because it's a vertical line. You have to say x equals negative 5 and x equals positive 4. And the good thing about vertical asymptotes is we could just do the domain, and I'm going to right off the bat. Let's go ahead and do our domain. Our domain is just going to be all reals. And then another way to put this is x cannot equal negative 5 and 4. That's another way to write it, if it speeds it up rather than doing except negative 5 and 4. Once again, vertical asymptote does two things. Gets us our vertical asymptotes and also gets us our domain. Botten, that's the hardest one. That is one we do not want to see on a test because that means we have to do extra work. And in fact, we have a whole section. If you turn the page, we'll just say what we're going to do with Botten. Botten is bigger on top. That means there's none. There is no horizontal asymptote. So none stands for no horizontal asymptote. Usually what that means is that you have a slant. It means you have an oblique or a slant asymptote. So when we have Botten, we usually have to check for a slant asymptote. All right? No horizontal, just a slant. So once again, I look at the powers. I have x to the third, x squared. It is bigger on top, so my horizontal asymptote would be none. And it's probably going to be a slant. A slant asymptote. Well, we can still find our vertical asymptote. Vertical asymptote is just setting the denominator equal to 0. So our vertical asymptote, set the denominator equal to 0. X squared equals 0. Well, that's just going to be x equals 0. Vertical asymptote at x equals 0. Let's go ahead and do our domain. Our domain is going to be all reals, except x cannot equal 0. Toughest one. You should look out, careful for bigger on top. Bigger on bottom, awesome, Bobo. Bobo just says y equals 0. Bigger on top, uh-oh. When they're equal, not a problem. All right, requires a little bit of work, but it's not a problem. So our last one is eats DC. That is exponents are the same. Are the same. Then we're going to divide coefficients. Exponents are the same. Divide coefficients. Once again, you look at the powers on the numerator and the denominator. You notice they're both to the first power. So our exponents are the same. So for our horizontal asymptote, we're going to eat DC. So that means we look at our leading coefficients, which are 2 and 1. I'm going to go ahead and circle them, and we divide them. 2 divided by 1 would give me y equals 2. That's my horizontal asymptote. Vertical asymptote, once again, is just set your denominator equal to 0. X plus 2 equals 0. That will give me x equals a negative 2, which also gives me my domain. My domain is going to be all reals, except x cannot equal negative 2. Boom, boom, boom. And this would be pretty easy to graph now. Each of these would be pretty easy to graph because you just graph your vertical, you graph your horizontal, plug a couple points in. The hardest part about these should be just plugging points in and Botten. But getting your slant asymptote isn't that hard. Yeah, Liam.
Is all real numbers except for something, is that just a quicker way of writing like from negative infinity to that, and then like from that to positive?
Is this a quicker way than writing? I think so.
Okay. So
I think this is...
It says the same thing.
Yes, this is the same thing. So if I'd write or negative infinity to negative 2, negative 2, or I should put a union in there. I just think this is a lot quicker, especially when you have, so the one above, which one? Do we have 2? This one has 2.
Yeah.
So you'd have to write negative infinity to negative 5, union with negative 5 to 4, union with 4. This is much easier than writing that.
I just thought it says
Says the exact same thing. Yep. All right, the next thing we're going to get to is Botten. What we do with Botten is the one we avoided yesterday, and we didn't really do an example in there. We just showed how to look for it. Botten. So Botten generally results in a slant or oblique asymptote. And this occurs when the degree of the numerator is exactly 1 more than the degree of the denominator. The degree of the denominator must be at least 1. If I give you botany on the test, it will fall in this camp. It will fall in the camp that you can actually solve it. All right, I'm not going to give you one that you just haven't seen before and you have to kind of guess and check your way through. So this will always be the case on the test. All right, my star here says, use division, either long or synthetic, to find the equation of your slant asymptote. All right, so we look at our powers. This is x squared and x. I'm supposed to sketch a graph of this. So let's start by doing our horizontal asymptote. Well, we don't have a horizontal asymptote. We are in Bottenland. Bottenland means that we're going to have a slant asymptote. And to get a slant asymptote, all you have to do is the actual division. You actually have to do x squared minus x minus 2 and divide that by x minus 1. You can use either long or synthetic division. Either one works here. All right, I'm going to go ahead and I'm going to use long division just because we haven't done it for a while. So long division would look something like this. I'll put x minus 1 on the outside. Inside our little division bar, we have x squared minus x minus 2. With long division, we look at our x squared. We ask how many times does x go into x squared? Well, that's x number of times. Now we take that x and we multiply it by x minus 1. So that's going to give me x squared here, negative 1x here. So we're going to have x squared and negative 1x, which should be there. Now the hard part about long division is you have to recognize that you are actually subtracting those values. You are subtracting those values. So we have x squared minus x squared, which gives me 0. And then we have negative x plus x, which gives me 0. Minus 2. Well, I can't go any further. X can't go in here. This is our remainder. This negative 2 is our remainder. So that right there is our remainder. But I really don't care about the remainder. Your slant asymptote is right here. That right there is your slant. So that's going to give me the equation y equals, let's put it back in black. Fade to black, as they always say. Y equals x. That is your slant asymptote. So you divide, and whatever your quotient is your slant asymptote. Once again, you just use division, either synthetic or long division. Why I did long division is because sometimes the one on the bottom is like x squared. You can't use synthetic. So I just use long division. What my quotient is my slant asymptote. Let's go ahead and find our vertical asymptote. Vertical asymptote is still the exact same. Vertical asymptote is awesome. It just holds steady. It just says set your denominator equal to 0, x minus 1 equals 0. So we have x equals 1. Let's go ahead and graph this. We're supposed to sketch a graph of it. Come over here. Let's make our tick marks. 1, 2, 3, 4 should be enough. 1, 2, 3, 4. 2, 3, 4. 1, 2, 3, 4. Call that 1. Call that 1. Let's do our slant asymptote first. Our slant asymptote is just a line y equals x. In other words, that's a line with a slope of 1. All right, so I'll just put a point here, point here, point here, point here. In other words, it's just that diagonal y equals x line. So that is my y equals x. And then let's just do our vertical asymptote at 1. Well, now nothing's different. Our graph is either up here or down here, in which case it'd be up here or here. All right, we still have our 4 places to put a graph. We're still just going to check points to see where it's going to be. So I want to check left of my vertical asymptote first. I'm just going to pick 0. 0 is left of my vertical asymptote, so let's plug that into the equation. So let's come up with an x, y type situation. I'm going to plug in 0. When I plug 0 in, that turns to negative 2 over negative 1, which just turns to 2. So I'd plot the point 0, 2. Let's go blue. So that means my graph is up here. It kind of looks like that. I'm pretty sure my other graph is right here. And why I say that is, what if you're on the test and you're running out of time? Right? And you're just running out of time and you're just like, I don't have time to plug in another point. Then you can just go, okay, I think it's here. I got a 90-some% chance that it's over here. But let's go ahead and plug that point in because we have time at class. Let's plug in 2. Let's plug in 2. Let's see if I plugged in 2 on here. That way I can just get the answer right off the bat. 2 is actually 0. Oh, yeah, that would have been pretty easy because it just would have been 4 minus 2 minus 2, which would give me 0 on top. So it's just 2, 0. So 2 zeros here. I would have been right on the test if I just had to quickly guess. Yeah, Liam.
Are they always going to kind of be opposite each other like that?
Yeah, like 90-some%.
Okay.
There's one on the homework that isn't, and I kind of put a hint by it. There's this weird case where it's not here. Maybe a better example would be here. It kind of does this, where it hugs down here, comes off, and then it shoots back up.
Okay.
That's pretty much it. That is Bobo Botten. Yeah.
For the first one the first asymptote that you graph the 0 to 1, would it ever be a case where you mark the accent stuff on?
Sure. You're talking about my slant, right?
Yeah.
So I could have y equals x plus 1, which would mean it intercept at y equals 1, and it would be up here. It also might have a different slope. I could have 2x plus 1. This is just going to be a line, an equation for a line. You just have to draw that line. This will always result in a line. Yep. So just know your y-intercept and your slope. Yeah.
For the blue lines, they always have to go through the point that you plotted.
Yeah, they should. Yeah. Because that actually is a point on the graph.
Yeah.
So you should try to shoot for that point. Sometimes it's kind of hard when you're drawing it. But yes, you should shoot for that. In fact, that's the only point we know for a fact is on here. The rest is just kind of a rough guess at what's going to happen as it gets close to the asymptote. All right, that is slant asymptote. The rest are just kind of special cases. All right, we're going to expand to one that looks like x over x squared minus x minus 2. Do we? Is that the one we all have? I don't know. I should keep asking that on these apparently. All right, let's go ahead and just do our horizontal asymptote first. Horizontal asymptote first. I'm looking at the powers. I have x to the first. X squared is bigger on bottom. Oh, that's awesome. Bigger on bottom means you're Bobo. Bobo ain't too smart. He just goes y equals 0. Bobo just says y equals 0. All right, vertical asymptote. We are going to have x squared minus x minus 2 equals 0. Once again, if it's not factorable, you have to put in the quadratic formula or something. This one is factorable. We're going to have x minus 2, x plus 1, which gives us vertical asymptotes at x equals 2 and x equals a negative 1. The only thing we're adding into this problem is now we have 2 vertical asymptotes, which gives us a new location for a graph. Let's go ahead and plot this. Maybe I should save some room because we have to plot some points. All right, let's go 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. Nice. Nice. All right, we have Bobo saying y equals 0. So we'll let Bobo have his y equals 0. That is just a horizontal line at 0. Our vertical asymptote says plot one at 2. So let's plot a vertical at x equals 2. And then we have one at negative 1, which is right here. All we did is we added a new location. We still have up here, down here. Now we have a middle up here, down here. Now we have up here, down here. This one's weird. The middle's a little weird. You have to plot a few points. You have to plot one close to this vertical, and generally you might have to plot one in the middle. All right, and the reason why you do that, there are 3 options for that middle graph. It can either look like this. It could look like this. I guess there's actually 4, because it could go like this, or it could go the opposite direction like that. All right, so our goal is to figure out which one of those are in the middle. So in the middle one, we're going to probably plot 2 or 3 points just to see what's going on. So generally, we try to pick one near the middle, and we pick some around the sides. All right, let's handle our left one first. So we're going to do an X, Y table. All right, I'm going to go left of this vertical asymptote first. So I'm going to pick -2. And just to save us some time, I plug these all in so they should all be correct. You end up with -0.5. These just aren't the nicest to plug in your head. So -2, -0.5. So at -2, let's go ahead and put this in blue. -2, we're at about halfway. So that means I am below, so we're going to have something that looks like that. All right, let's take care of the center. Let's take care of the center, and I picked 3 points. I picked -0.5. I also picked 0, and I also picked 1. And so all of these are just for that center. And it's always good to pick 3. I always shoot for one close to this vertical asymptote, one close to this one, and somewhere in the middle. All right. When I plugged in -0.5, I got out 0.4. When you plug 0 in, you actually get 0 out. And when you plug 1 in, you get -0.5 out. So plotting that points, at -0.5, it's up about 0.4, which might be about here. Then we have 0, 0. And then we have 1 about halfway, something like that. But that's enough information. We realize that it must go like this. And it must go like that. It's the only thing I can do. All right, now I just have one more point I have to pick. I think I picked 3. I should have picked 3. I did pick 3. And when I plug 3 into the equation, I get out 0.75. So 3, 0.75, that would be maybe about here. Maybe if it lets me do it. And so we have a graph that looks like that. I think rational functions are as hard as you make them. All right? Your vertical asymptotes are always just set your denominator to equal 0. And if you know Bobo-Botten eats DC, you can make your vertical and horizontal asymptotes. Then it's just plugging in points, which you've been doing since Algebra 1. Just plug points in to the equation. The only thing you can have is maybe a silly math mistake where you plug it in wrong. But if I see this table, and I see your vertical and horizontal asymptotes, and I see one point is plotted wrong, I'll realize what you did. You just lose half a point for a math mistake. All right? Any questions on this one? Yeah?
So, like the normal graphs, are they opposites of each other, will they still be?
Most of the time. Yeah. Yeah, most of the time they'll be opposites. So if you're running out of time, yeah. If you're running out of time, if you're really running out of time, I would just plot one of these, and I'd plot a point close to here and here. And if they're both negative, then I know it goes like that. And just make a, because it shouldn't go above this. So if this was a U shape, it's not going to go above this line. If anything, it's just going to hit it. So at least you can come up with a nice sketch of that. All right, one more problem. We're supposed to sketch the graph of x squared minus 9 all over x squared minus 2x minus 3. This is kind of a special case problem. And that is because if you notice the top I can rewrite. That's a difference of squares. So we're going to rewrite this equation. We're going to rewrite it as the difference of squares. So that would be x plus 9, not x plus 9, x plus 3, I should say, times x minus 3. And then on the bottom, we are going to factor it. So I'm going to have x That must be a minus 3 and an x plus 1. Now, I did this for a specific reason. Remember from yesterday, if they cancel each other out, we can do the canceling. So we can actually cancel these out to make our equation a little simpler. So I can cancel those out to make this equal x plus 3 over x plus 1. But before I cancel it, I must realize that there is a hole at x equals 3, and that's going to come back in a second. There's a hole at x equals 3, so don't just subtract it out. Recognize that there is a hole. But now we can just use this to do everything else. All right, we can use that to come up with our horizontal asymptote. Our horizontal asymptote, our powers are the same. It's x over x, so that's eats dc. Eats dc says divide the leading coefficients. We have a 1 and a 1. So eats dc gives me that we should have y equals 1 over 1, which just equals 1. Y equals 1 is my horizontal. Our vertical asymptote is just going to be that x plus 1 equals 0. So x equals a negative 1. Boom, boom, boom. We're almost there. We just make a pretty sweet graph. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Whew. I have a horizontal asymptote at x equals 1. Let's make that asymptote. I have a vertical asymptote at x equals negative 1. We have a hole at x equals 3. That is one of the points I'm going to plot. All right, I could pick whatever I want, but I should at least have one x equals 3 in my plot. Now, here's the thing. If I plug x equals 3 into this original equation, it's going to come up with an error, because 3 actually makes the denominator 0. So what we're going to use for our xy is we're actually going to use this new formula here. So when I make my x, y, and I pick my points, I am going to use this equation. I'm going to plug it into that equation. So the first thing I'm going to check is the hole. X equals 3. That is my hole. That's the first point I'm going to plot. So I'm going to plug 3 into here. So I have 3 plus 3 is 6. 6 over 4, which is 3 over 2. So when I plug 3 in, I get 6 over 4, which is 3 over 2. Now I'm going to plot that first so we don't make any mistakes. 3 over 2, all I really care about is, about halfway up here. So we're going to plot that point. We're not going to plot it as a closed point because it is a hole. So we're actually going to draw a hole at 3 and 3/2. So I'm actually going to put a circle there. I'm actually going to put a circle there because there's a hole. But I already have a point, so I can do the rest. All right, then the other point I picked was negative 2. Negative 2 results in negative 1 because you'd have negative 2 plus 3, which is negative 1. I'm sorry, that'd be 1 over negative 1, which gives you negative 1. So it's negative 2, negative 1, negative 2, negative 1 would be right here. That is a closed dot because it's not a hole. And then we're done. So always be careful to look out for holes. If there is a hole, use that as one of your points because you need to find it anyway. You need to find your hole anyway, so why not make it one of your points? All right, any questions for me? Let's rehash what's happening. Next Monday, test corrections are due. All your grades should be in, minus homeworks and stuff. I mean, your test grades should be in. Friday, I am not here, but it won't be that big a deal because tomorrow We have one last lesson. That's it. And the test is on Wednesday. So we have one last lesson tomorrow. Friday will just be a worksheet to do more practice on this. Monday and Tuesday will be review days. Wednesday would be your test. We have plenty of review days to get this stuff done. All right, it's just lots of little stuff that you have to kind of remember.
Who's
All right.
signing?
What was that?
Who's signing?
I
Steve S.
always forget his name.